Hello eye tracking community, my name is Michael, and in this tutorial we will talk about how we can recalibrate our eye tracking data with Blickshift Analytics. In this tutorial I will teach two things. In the first part we will have a look at how you can identify errors of the calibration in your data. And then in the second part I will show you how you can recalibrate the data with Blickshift Analytics so that you can continue your data analysis. On the screen we can see an eye tracking experiment where the participants have to get some information from bar charts. We can see 9 participants here. And when we look here at the first participant, this looks really like a perfect scan path. I know this because we have integrated some layout features which can show us later during the analysis. So here in this example, looking at the scan paths, that the calibration has been done correctly. First, we told the participants that they have to start their eye movements from the center of the screen. So in this case, check. Then the task has been to find the bar with the label 7 and then to estimate the value of this bar. And when we look at the scan path, we can really nicely see that the eye movements are going down to the x-axis, almost directly to the label here when we look here at the fixation number 3. So the participant identified the label 7 here and then went up to the bar peak and then here to the y-axis and altered the eye movements between the bar peak and the y-axis. And by integrating these markers or these special areas where we know that the participants will move their attention to, we can later identify some errors during the calibration, for example. So let's look at the other participants. We move to participant number 2. So what we know is that the participant should have started the eye movements here from the center of the screen and should have then went down to here the x-axis. And what we can see is this participant didn't do that. Or better, perhaps there was an error during the calibration because the overall structure of this scan path looks quite okay. It just looked a bit shifted downwards. So let's go to participant number 3. Here we can see the same effect, but much better. So this participant really started the eye movements from the center of the screen, searched for the labels, went up to the bar peak and then tried to find here the right value. And what we can see here at the bottom is really that this participant moved the attention over the x-axis, but the data shows us wrong values here on the vertical coordinate axis of the data. Relatively constant over the whole recording here. So let's look at all the participants. So we zoom out a bit. Number 4 looks okay. Number 5 looks okay. Number 6 looks okay. 7 okay. 8 okay. 9. So check only selected. We zoom in. Same data quality or same behavior starting from the center of the screen going down, but here we have this offset. Scan paths which show such a behavior are a good indicator for an offset error during the calibration. There are several reasons why this can happen. We will talk about them in later tutorials. What we have to know at this point is that it looks like 3 out of 9 participants show this behavior. So something went wrong during the calibration or during the recording. So calibration has been done correctly, but then something happened with the participant. Perhaps person moved a bit or the glasses, so the head-mounted eye tracker, moved a bit on the nose. All these can be reasons why we have these offsets. As I said, we will talk about that in another tutorial. So in the second part, we will talk about now how we can recalibrate. So how we can remove this offset from the data. Because if you think about 3 out of 9, this is more than 30%. This would be a lot of data which I just throw away because of a wrong calibration. Before we go into the next part of the tutorial, I want to emphasize one important aspect here. This data comes as it is from the eye tracker. In the next step, I will show you how you can change the data with the tools integrated in our software. However, what is really important is to know that in this moment, when you change the data model, you bring in a new assumption into your data analysis. And when you report your results, you're writing an article, you write a report for your client, it's very important to tell that you have changed the data based on assumptions. Because it's not the original data anymore, which comes from the sensor. You clean it, you change it, and you really have to argue why you're doing it. And you have to be really sensitive how you do that. Because as I said, you bring in a new assumption which was not included in the original data. So let's change now the data. In Blickshift Analytics, that's easy. I go to the data source, I make a right click, I say Analysis, and then I open the column Computation. We want to change the Y coordinate, and then we will implement here one line of code. If you want to learn more about this column Computation node, please have a look at this tutorial. We create here a new column, which we will call Fixation Y Map Recalibrated. Int is quite okay. And then we say we return now to this new column values, which we take from Fixation Y mapped, so from the original data, but we add some pixels because the coordinate origin in this visualization is on the top left, so in this corner. So the coordinate system here is top left, the y-axis goes like this, and the x-axis here to the right. I go back to the column Computation, and then let's add here, for example, 50 pixels. I click somewhere here, so column Computation calculated, and then we want to visualize the results. I make a right click on the column Computation, I say Visualizations, and then Scan Path. So here we activate all the participants. We use the same zoom factor, so 22. But here, instead of Fixation Y map, which is the original data, we choose now the new one. So Fixation Y mapped Recalibrated. So, and when I go down here of the scroll bar, you can see, okay, it looks better, but not perfect. By the way, we also changed all the other participants as well, which I don't want to. So I deactivate P1, P4, P5, P6, P7, and PI, and only change the data of these two participants. I go to the original data, deactivate here the others as well, and then we can compare the ones with each other. 50 pixels is perhaps not enough, so let's increase that by another 50. Yeah, looks better. Original data, recalibrated data. I would go with this recalibrated data. I zoom in a bit so that we can better see it. I remove the panel, and here we can nicely see the recalibrated data in Blickshift Analytics. The next step now would be to export this data and to re-import it so that we can bring it together with the other data which we haven't changed. And how we can do that, I will show in one of the next tutorials. Thank you very much for watching. If you like this tutorial, please push the like button, subscribe to our channel, and activate the bell so that you'll never miss a new video on this channel. And I'm looking forward to seeing you in the next tutorial.